everybody. Next week, you're going to hear from a researcher at UC Berkeley talk about cyber physical systems. Today I have the pleasure of introducing you to Jonathan Bachrach, who's going to tell us how to eat robots. Let's welcome our speaker.
Okay, thanks for having me. So I want to warn you, I'm going to talk about some dangerous material here. This is a serious and disturbing talk, and I want you to be disturbed by the end. I'm going to present some background. I'm really starting a conversation. I don't have all the answers. But I want to present to you a common sense approach, kind of an engineer's approach to a looming, very catastrophic situation. And at the end, I'm going to present kind of last in like 8 slides, like an arc of my work in the last 10 years. So there are some trends that are super disturbing. While we are growing overall, the median income is going down. There's growing inequality between rich and poor. It's harder for you guys, maybe not you specifically because you're computer science people, but everyone else to get jobs after they get college. They are going into great debt to go to college. More people are getting jobs that they're sort of overqualified for, the part-time jobs, et cetera. And we're not even keeping up with population growth overall for our economy. And I have to say, you guys got to admit, this is the weirdest presidential election ever. And now they're talking about a revolution, perhaps, if Hillary gets elected. So, I mean, this is really crazy times. They're calling what we're involved in now the 4th Industrial Revolution. Say the first one was about automation, or creating basically textiles, making those better, and then there's electrification, and then in the 70s we had the advent of the computers and information World Wide Web. But suddenly they said this is the 4th Industrial Revolution, and I think what really captures it is that it is extreme automation, extreme integration, and distribution of compute everywhere. And I just want to call out that, like, traditionally industrial revolutions have been good. I mean, we've had more free time. We are doing more things that are in the spirit of what makes humans amazing. And overall, the outcome is that we have less labor is needed to get the things that we need. Okay, so this is a great example from this Humans Need Not Apply video that I encourage you all to check out. But it was like thinking back, like early 1900s, the horses were out there, and they were doing a lot of the transportation work. And imagine from the perspective of a horse who's thinking, here, these autos are coming, maybe they'll make our lives even better. We're not kind of in the farms anymore, pulling, these heavy plows anymore. We're in the cities, this kind of thing. But unfortunately, we know what happened. The horses got replaced by autos, and there's very few horses around anymore. And there was no entitlement for the horses to have jobs, or that technology would create these jobs for horses. So now consider our plight as humans, okay, with robots coming. So why is this different from any other industrial revolution? And I think it's just the sheer speed. I mean, things are being automated at incredible exponential speeds. We're really starting to see the effects of like 30 years of Moore's law, doubling. That's exponential. That's incredible. And technology is coming online faster than we can retrain. And also, like, just consider, I mean, computers are general purpose. And with AI and machine learning and big data, they can learn anything. They have access to way more than we ever had before. So, you know, there's a lot of indication that they could become, you know, much cheaper, much more affordable, a better option than humans in the workplace. And let me just go through some jobs that are pretty widespread. Transportation jobs, self-driving cars are coming online. Long-haul trucks are not far behind. This is a picture of Otto that just got bought by Uber for $680 million. And then factory warehouse jobs. There's like there's entire robotic factories. I mean, I just like this is a picture. Okay, so this is a Tesla factory that's pumping out cars. These are general purpose arms that are able to do lots of tasks. They're able to be trained and be super versatile. This is Kiva Systems, which is really doing a lot of the work inside of Amazon warehouses, so very few humans need to be there. And what they can't do, it's getting done now. So like, for example, like being very good at picking up particular parts and all, the robotics now are coming online. There's strong economic incentives for companies to provide those technologies. And then retail jobs. I mean, I buy a lot of stuff online. I'm sure you guys do. But they're talking, there are these kiosks that are fully replacing you know, a store that give you all the advantages, but like even the time to ship is going down quite a bit, so that, you know, Amazon is like actually pretty good with return policies and all that sort of thing. And then like what's left of brick and mortar stores, they'll, you know, probably do a lot of automation within the store to reduce the need to human labor. Fast food jobs, people now are doing startups that are automating the cooking and serving of fast food, and I think most people would probably, if the food was cheaper, would go to those places. They're doing it with sushi. I could imagine the same thing happening with coffee and so forth. And then finally, those are all like kind of manual, low-paying jobs, but all the high-paying jobs are maybe even a more exciting opportunity for capitalists because they can make a lot more money. There will be more profit if they can replace these more expensive white-collar jobs. And so we saw with IBM Watson, you win Jeopardy. Now, you know, they beat the Go champion, Google, and their subsidiary beat the best Go player. But there's a lot of routine, kind of predictable aspects like accounting jobs, legal discovery, and then, you know, talk about doctors, and IBM's kind of like really pushing hard to replace a lot of the work inside of medicine because they think, and it seems like it makes a lot of sense to me that I would like a doctor that had access to all the data, you know, and make rational decisions about healthcare. And so anyways, that, like, if you think your job's safe, I think this is a really good opportunity to replace even more jobs in places that seem pretty sacred. And so just in general, you know, the jobs that are probably targeted most as low-hanging fruits to be replaced are repetitive things that could be predicted through machine learning and so forth. So we can just basically watch humans do their jobs. And this is part of the actual plan for certain companies where they bring in certain specialists like accountants, and then they learn from the accountants, and then eventually, and they automate some of it, but have the accountants do some extra work, and then the accountants are replaced. And so let's just look at this. This is like U.S. Bureau of Labor Statistics. Look at all the jobs. And so one thing to point out, and a lot of people have poured over this data, but if you look at, you know, all these jobs are pretty traditional, and of course they've been turbocharged by computers, but, you know, computer and math, there's not very many here that represent things that are new in the last century or so. But, you know, just looking at the cumulative percentage of these jobs, I mean, I could tell a story where pretty much all these jobs would be replaced, and they're really low-hanging: office, admin, sales related, transportation. I've already covered a lot of these. Health, certain areas we could debate about, but there's a lot of fat there that are stuff that could be targeted, a lot of routine jobs. And so there was a really nice study at Oxford on, what are jobs, just go through that list and try to like figure out what are the ones that are amenable to automation. And they kind of they came up with some things they thought were kind of harder for computers to capture, and that was, social skills, like extreme sensory motor type activities. And then a big one is like creativity, ideation, ability to come up with ideas and think out of the box. And so they went through that, and then they sort of said, what are the jobs that have those qualities and don't? And they said the ones that don't have those qualities, there's like 45% of that whole list are jobs that could be replaced. And they're thinking this could be done within 20 years. 20 years, okay? So now I just ask the question, like, what about these? Are they even safe? And here's like, art is like seemed like a sacred thing, just be creative and all. But we see now the advent of this kind of Google Deep Dream, which allows you to take neural networks and train up on various styles and apply that at a higher level and be creative. And so, they're really, this is something I've been working on actually for many, many years. And so I don't believe that it's anything sacred. I think computers could learn to be creative as well. And just one little story was that there was, there's a story about one of the top chess players who had come up. He was a child prodigy, and he came up with some moves that were just remarkable, and everyone was saying, wow, this is incredible. He's such a genius. And then they gave the same moves to one of the big computer chess players, and they came up with the same moves. It's like it's really like potentially a lot of what we think is creativity is really just kind of more brute force, more of exploring a bigger search space and then finding those little needles in the haystack. But we can't introspect how we do things, so we kind of attribute it to this kind of magical notion of creativity. If we do what they're proposing, this would be catastrophic for us as a society. I mean, the Great Depression had 25% unemployment. Here's a picture of a food line. People that don't have jobs need to feed themselves. There would be mass starvation and homelessness. This is really, really bad. So that's the setup for the talk, all right? Hopefully you're a little bit disturbed. I'm very disturbed. This is looming very large. How do we respond? Obviously, if you're a person, and I'm a parent, I got kids, what do I tell my kids? Okay, we'll definitely work on those skills that are less amenable to automation. But how do we respond as a society and as engineers? And so I just wanted to look at some of our options, then I'm going to propose mine from common sense. And maybe this is just like, this is what I have available to me, but I think it kind of makes sense. One idea is let's just get rid of the robots. Let's be Luddites. This was a response earlier to one of the industrial revolutions, and I don't think that people can give up their technology. Everyone's very addicted to it. It gives us a lot of benefits. But of course it's a double-edged sword. And the other thing too is that we have this very strong capitalist system that makes a lot of money off of these electronic devices and innovations. So I think it would be unrealistic to say that we're going to stop the advent of robots. We could ignore it, but I think I'm trying to make the case for the fact that we're going to get a lot of unemployment and starvation. And so, we could let it happen, and then because of the stratification of wealth, we would have no more middle class. We would just have a lot of poor people and a lot of really wealthy people. And we could consider like a version of like a a gated community kind of. And this is like one picture of that from Elysium, if people have seen the movie, where we had like the wealthy people were on the satellite and the the unfortunate people were stuck on Earth. In this case, they were actually working in factories, which I don't think would necessarily be there anymore, but it would be a way to kind of keep the people away from the wealthy people and keep the unrest at bay. But I don't think that that we would be able to stomach that first. I'm hoping that democracy was invented to actually prevent this sort of thing from happening. But again, I don't think this is a realistic outcome. I think we will rise to the occasion. And then there was this in this book, The New Machine Age, was arguing for this idea that we could race with the machines. And after the creation of this computer chess that was able to beat all the grandmasters. They came up with this idea of freestyle chess, where players would play with the computer chess to have as much compute as you want. And then it turned out there were some really nice little results where someone that wasn't even that great at playing chess could actually won the tournament by using multiple computers, giving them. But then, I think there's a lot of arguments. I'm very suspicious of this. First of all, why couldn't computers be that person looking at all the answers? And this is kind of the way Watson did Jeopardy. It basically had a lot of experts kind of giving it ideas about how to answer questions. It was like trying to consider all the options. It just did it all in parallel with parallel processing. Same kind of thing could happen. We could have a computer go one level up and replace the human in the freestyle chess. Other thing is it's just really hard to interoperate with users. And there would just be less people that could interoperate with computers. I'm not saying it's not possible, but I feel like this is more difficult. It'll take us more time to actually get to a point where we can augment human intelligence with computers. So we're left with one more option. I'm saying this is an exhaustive list, but we could redistribute wealth. And so, and I have to say, right now, my thinking is the American dream is pretty much over for all but the fewest, and I know people now aren't willing to admit that, and that's why Trump is having a lot of success. But I think it is pretty much, and so we are going to be under increasing pressure to redistribute wealth. This has historically been really unpopular, but I think that we have a moral obligation to share this technological bounty with other people, with the rest of the. Well, I think we will, as a society, do better to do that. I don't think it would be tenable to have this kind of split society. But so now people are proposing real ways to do that, and one is guaranteed basic income, and that is to pay each and every person a fixed amount per year. This is not a new idea. This has been something that's been bipartisan. It was popular during Nixon's era and even before. Even Thomas Paine talked about giving people a certain amount of money when they were starting out at 21 and so forth. But yeah, the problem is, okay, so let's just go through this. Okay, so how do we do this? Okay. Well, one thing that's really nice about this is that the current social welfare system has a lot of overhead associated with it. So we have to have people come in and interview and see, do you really need it? And then they keep working with you. Do you still really need it? And then they're really kind of in your life, so they're really saying you got to use your money in this particular way. So this is a really kind of clean idea that removes a lot of the overhead and keeps the government out of your your life, so that you are free to use that money in any way that you want, including potentially starting a company or whatever you want to do. So there's a lot of people excited about this, and just to say that the federal poverty level is 16,000, but if I've looked a little bit about what people think it costs, and 30,000 is kind of in northwestern Pennsylvania. If you have an adult and 2 kids, what would be kind of poverty line income just to kind of pay for all your expenses, health care, taking care of the kids, everything. And so, what are the things that are constitute basic needs? We have food and water, shelter, energy, clothing, sanitation. These are all kind of common sense things, but I just want to like list it out here so that you kind of know, because when I get further on about what we have to take care of. And so this proposal is really throwing money at it and letting people pay for these things. So the problem with guaranteed basic income is it's gotten a lot of people excited, but there's also critics of it, and I think I'm a little bit of a critic of it. I think there some form has to be true, but let's just look. Let's peel it back a little bit, and it turns out that it would take, if you were to give out 10 or 20K per person times 200 million people, and this is again like I should have said that basic income was you give it to everyone. You don't say whether you're. Well, I did say that, but like just let's be clear: 200 million people. Let's give it to all the people that are working age in the United States. Okay, and that would be $2 to $4 trillion. And so, right. And so like basically, our tax base is about 6.4 trillion. Even if we cut existing welfare, we would be short about $1 trillion or more, depending on how much money you give. And even if you gave 10K, which we can't afford, that would not be enough to get over the poverty line. And so there are other options that people have advocated. You can read a lot about this, including negative income, which kind of gives you a little bit more of an incentive to work, and then earned income credits, which basically you get some money back if you're below a certain line, only if you're working. So you have to work and then you get a credit. So there's lots of versions of this. Right, and so I think, you guys have witnessed some form of debates in the government, like back and forth. And, it's really hard to get things done, and especially these are the most contentious things to propose. So, and I'm a little guy here, that's, an engineer. And so I don't really know how to make that happen as a policy, but I think some form of it is necessary. But I'm an engineer, so like I think that we're seeing robots as a problem, we should see them as a solution. Okay? So now we're getting to the thesis of my talk, which is that we should don't fight the robots, but invite them, make them better, focus them to do more of the basic needs, to basically reduce the cost of basic needs so that something like guaranteed basic income could go a lot further. Okay, so here's my concrete proposal. A little bit tongue-in-cheek, but I actually really believe this, seriously. I'm saying that we should give a robot to each human at birth, okay? This robot would be your assistant that would help you in all your needs, all your basic needs. We would add a right to the Bill of Rights, that this is a right that our great society gives to all the people. And perhaps we would even consider giving people 100 meters squared in a robot, But overall, we would have this reduce the cost of all the basic needs and enable people to survive. And so I just want to touch on a couple topics that you can debate me on this, but personally I don't think people should have to work. They should optionally work if that's gives them a good feeling, good value in society. But most jobs are really horrible and they're mind-numbing and backbreaking and not celebrating what's great about humans necessarily. And back in the Roman era, this is Jerry Sussman kind of told me, back in the Roman era, there was a life they created, a life of leisure for the Roman citizens, and they did that by enslaving a lot of people they conquered. But here we have this opportunity to use robots as our slaves to enable us to have a life of leisure and not have to do work. The other thing is, I should say, is that I really do feel like work and money really leads to a lot of exploitation, and this is endemic. If you look in your life, a lot of things, choices you do, you compromise things because you need money. And at the lowest rungs of society where people are really desperate, there's a lot of exploitation that happens. It's super unsavory. And so I would really love to kind of be liberated from these shackles and again, transfer this abundance to everyone. Because we have earned it as a society. We figured out how to be really efficient. Let's transfer that to everybody somehow. And now I'm saying let them eat robots. I'm saying, give everyone a robot at birth. Really, don't take me literally about that, but just in the sense, do that as efficiently as possible. If it's a system of team of robots, if there's lots of robots, it doesn't have to be one robot, but just basically robots that are going to help us lower the cost of basic needs. Right, and they're talking about this with self-driving cars, kind of having a pool of cars and so forth. And then you also say, well, how can we afford that? That robots are really expensive. Well, we got to work on lowering the cost of robots, and there's been a lot of talk. I think this is like a great research area to get into, like how to get robots to repair robots, to manufacture robots, and people are talking about exponential manufacturing and sending robots out to space stations, how you kind of have to do that by necessity. But here we're also in a necessity situation where we have to dramatically lower the cost of producing robots so that we can give them away to people. And this is like an example of, kind of a hokey version, but like a great first step towards self-replication. All it does is it basically can print all the plastic parts in itself. So the next generation, it can print. But we got to figure out how to bootstrap that. Our bodies do a great job at that. We got to figure out how to do that kind of in an engineered system. The problem is that robots are notoriously hard to design. And so the second part of my proposal is that we work on better robot design tools, okay? And so, just kind of say it as quickly as possible. Designing an electromechanical system is one of the hardest things possible in engineering. It's incredibly low level. There's lots of dead ends that you get into. You've got these very fragile design systems. They're not comprehensive in any way. They don't acknowledge the manufacturing constraints at all. There's very little reuse. There's no optimization of the entire system, the embedded system of both mechanical and electrical, nor software. The opportunities are lost there, and they're made a lot harder. And so just if we think about what engineering is, I think it really is like trying to articulate what do we want out of something? How would we judge success? And then saying that engineering really is kind of managing those trade-offs. And like we'll say, not all the things we want can be possible. So it's like, 3 things you want, you got to pick 2. But we got to figure out how to do that. When I teach a class in like Vlsi system design, that class is really all about, area, power, speed, all that stuff. How do you manage that as an engineer? But we want to do it at a whole level above that. We're doing it at way too low a level. But we do have to sweep through design space. One of the things that was really cool was this system that happened a long, long time ago, Evolving Virtual Creatures by Carl Sims. So he had evolved these creatures, and he had expressed, like how you would judge success at walking, but it would automatically evolve like we do as creatures in the real world. But like we need to harness those ideas in more of a focused engineering discipline. And then the other thing is we have to dramatically design at a higher level. So each design point has to be automated, so like we don't have a lot of labor in order to evaluate success. Right, we have to make everything higher level, lots fewer details. We have to, again, codify this kind of design intent, and then have everything kind of flow from that as much as possible. And adapt to different material systems, decouple those decisions so that we can take the same design and have it output for a rigid robot or inflatable robot. The same kind of general idea would be would be encapsulated in the design. And now I just want to step back and say, you know, tools are, through the ages, like a great enabler for society. From spears to bow and arrows and hammers and all the sort of things we take for granted, have really just triggered completely new eras in society. Those inventions, and so now I think our greatest invention, really, of the recent past is a computer. But no less important is programming languages and the ability to make them do what we want. Without that, we wouldn't be able to get where we are. And so this is kind of like a fun, path through different programming techniques from the lowest level to higher level languages. I think it really just stops at Ruby as a programming language for those that are familiar with that. But we have a lot further to go. And I just want to step back. What can we do to impact positive change at all? And so I think we need to get as high in the food chain as possible. If we develop really good tools, then we empower lots more people. We have a lot more potential for impact of other people using those tools to make things. Maybe we won't make a cool robot, but we will empower a lot of people to make cool robots that will do real things that we need. And so, sorry. This is the picture of the programming languages being developed over the ages. And I just finally, really computers are we're just starting to really understand how awesome computers are in terms of what they're capable of, basically being able to simulate, predict, and control the world. And the applicability is limitless, but we just need to really harness that power as best possible. And so really now thinking about robot tool design and robots themselves, robots are sort of the embodied realization of a computer. It's a situated compute engine that can sense and actuate in the world. And robot design tools are really this generalization of programming. So there had been a lot of talk about giving people the means of production, and this is kind of a picture of the third industrial revolution. We're already on our fourth, but from The Economist, of 3D printing and all that sort of thing, and how that's going to kind of democratize production. But I really feel we need to also give humans the means to productively design, we're basically the robot design technologies are just completely in the dark ages. They're way worse than where we are with software. And then furthermore, we really have to work on collaborative design. So I would say the biggest thing that we can work on is kind of collaborative design tools that allow us to work together and kind of amplify everyone's effort as much as possible, so that we can kind of parallelize the solving of our design problems. I think once we do that, we can empower a lot of people, and there is opportunity still in the long tail for people to add value to the economy. So I think with the basic income and the designs, the means of production and means of design, productive design, that people will be able to contribute and add a more comfortable existence. So this is a great book on that I encourage people to read. But so now let me just step back one more time and say, here's my approach. So what we're going to focus, what are our basic needs, and we're going to develop and distribute tools that will help us achieve those. And so I would say first step is we just got to get to the point where we can do as well as software design in these kind of more physical design areas. And these are things that we take for granted, but we really need to bring over is much better abstraction, better techniques for programming that work really well and that get really good reuse, agile design techniques of open compilers, version control, all the stuff we totally take for granted is not available in the physical design world. Okay, so now I'm gonna go through a whirlwind tour of some of the things I've done in the last 10 years. And you can look at my website for more details. But I came out to California and co-founded Other Lab with Saul Griffith, and we were thinking. I was really thinking hard about like these ideas, and really like how to harness these rapid fabrication machines, and in particular, looking at ones that could handle kind of more practical materials like laser cutters. So we were thinking really hard about like coming up with this idea of like a compiler that would take a higher level description of a design and then automatically rationalize it into parts, produce all the joinery, do all the layout, and kind of also have instructions for assembly. So make this whole thing automated as much as possible and retargetable for particular outcomes. And so we did a whole space of these. There are all sorts of decompositions from 2D, 3D, 3D design into 2D, 3D. So this is just one fun interface where you could kind of, take a 3D shape and decompose it into kind of sliced parts and have it automatically work out all the joinery for you, do all the labels and layout, and then step you through an instruction for assembly, which is all this stuff was like really, really hard to do before this, and so this is like one step towards bringing software into the process of physical fabrication. I joined Berkeley around 2010, started this project of software-defined Vlsi hardware. It's called Chisel. We were bringing in software advantages, like I was saying, to design. And until then, we kind of had these ad hoc languages like Verilog that were mostly structural. You kind of what you see is what you get mostly, but in practice, practitioners were actually writing scripts to produce Verilog because they wanted designs that were more reusable, more generative, where you could parameterize them more powerfully. So we just said, well, if you're going to do that, you might as well just bring that completely into a programming language and make it as seamless as possible so you can leverage as much of the existing power of the programming language. And then once you do that, once you make these generators, then you can kind of just sweep through the parameter space and evaluate all your designs to see how well they're doing. And then more recently, we've been looking at an open compiler where we could do passes, we could add passes that would be important, so you can kind of factor your design into specification and passes. We've built a lot of chips. This has been pretty successful, and so I think we can say that it's worked out all right. We've been able to, with very small teams, be able to tape out chips like at unheard of rates, like on average, kind of every 6 months. And we're getting kind of record, at least for academia, of clock rates, and so we're able to actually do it in a way where we don't incur a cost to the abstraction and the design, which is really important for people that are doing high performance chips. Then I really wanted to get back to doing physical fabrication, mechanical, and so forth. I teamed up with a couple students, Duncan Haldane and Austin Buchan, who we came up with this class called Computational Design Fabrication 2015. There were some ideas of like doing programmatic design, but we wanted to do something that was way more powerful, that was kind of above the sort of like modeled the kinematic structure of these articulated models, and then had a full flow all the way to parts, and you could do simulation and just kind of like encapsulate and model all the aspects so you could manipulate them and be a lot more productive. And so just wanted to show you one outcome. Was Jay Reddy was one of the students. He was an undergrad at Berkeley, and he really got the idea, and he built this. He was inspired by Theo Jensen's Strandbeest, which is at the museum here in San Francisco. But this is like also an example of like a linkage, a walker that uses mechanical linkages. So he just wanted to generalize that. How can we make a generator that generate a whole family of these? So how can we parameterize it and have it solve for all the issues you have to do by hand of interference of parts and so forth, and solving from a higher level of like how do you go from some target trajectory like a walking gait into like what are the linkage parameters that we need, what are the lengths of all the parts, and so forth. So there's a lot levels we could go if we could just work and figure out how to do that. He made a good step towards that. More recently, I've been working on this concept of, I've been really struck by the idea of like these new rapid prototyping machines. Like this case, it's the desktop mill. The other mill that can make a board in an hour, but we can't design a circuit board in an hour, so we can't even keep up with it. So it really was kind of like, posing this thing, do you want to make this in code? In code, like I was appealing to the programmer spirit, so it was really like PCBs for programmers. Have you ever wanted to design a circuit board where we're intimidated? Do you want to like not have to deal with a lot of analog issues? Have you been frustrated at the tedium? Do you want circuit board design to be more like software design? And and also like fundamentally we just want to keep up with the speed so we can crank out boards at a really high pace. And so the flow was that we could have a hardware description that was really kind of represented what we care about, like what are the peripherals on the board that we would care about, and potentially like where do we want those things, but all the other details like where is the compute and what are the pins, what are the devices, all that stuff would be done for you. And then you also write in your application code, which uses kind of abstract peripherals, and then from there synthesizes both the board and all the embedded hardware and software that you need. And so inputs this, and you get compiled firmware and networking layer, including, we have a bootloader and all the other stuff. So making like dramatically easier to crank out boards. So we just had a paper in IROS where we really targeted on building robots, electronic parts of robots. And we were able to build this Pong board, which parameterized in the number of LEDs. So you can play Pong with these physical LEDs. And you can parameterize by the number of LEDs. And everything flows from that, the number of microcontrollers and so forth. And then we did things that were kind of near and dear to robot practitioners, where you want to do like a robot arm, you want to split it up into boards with a master and then control loops on each board, and then like just interoperate with existing compute and robotic platforms. And this is the line following robot down below. So okay, so I'm near the end here. Call to arms. I think this is a great moonshot that we could all embark on. I'm calling for the invention of much better electromechanical design tools and focusing on those towards basic needs robots that can help us survive in this very dangerous time. I have a whole list of steps. I feel like we have to just get to where we are with software. Get all the abstraction reuse that we take for granted, but I think we have to go much further, and we have to optimize over design space, and we have to go from little systems to hybrid combined systems, deal with fabrication, construction, and eventually we have to worry about the cost of the machines and how do we deal with the environment, make them more sustainable, and more practical as we kind of integrate towards more miniaturization. I want to just say that what is let them eat cake? For people that don't know, let them eat robots came from let them eat cake. So this was said purportedly by Marie Antoinette when she was told that the peasants had no bread. She says, well, let them eat cake. It's like kind of, you're missing the point. People don't have the means to buy the bread. But it was if you dig into it a little bit, falsely attributed, actually from Rousseau's autobiography about a princess. So it just all got connected. And so, potentially I'm guilty of the same sort of sin here that, I'm coming up with the wrong solution for this problem. I'm open to all sorts of solutions. I'm a humble engineer. I'm appealing to common sense. I feel like we do have a way to engineer ourselves out of this problem to some extent. It's not an entire solution. I would say people should watch this movie immediately. Humans Need Not Apply. And I can give you all guys these slides so you don't need to copy it down right now. This is a fantastic book. I borrowed heavily in the talk, and he's someone that's coming from software design or software industry, and he also has a master's in business. He has a really good way of writing too, and he's really gone through. He really argues very strongly for guaranteed basic income. When it's good to read how he says it, but he covers a lot of great topics. I love this book. I want to believe that people out there can be we can democratize design and production, and this is a great book that captures that. And here's a bunch of references, and thank you very much for inviting me.
Questions?
It sounded like you're talking about the automation of tasks, and it occurred to me at the beginning that if you could automate the automation of tasks, that'd be like the singularity of automation. And then it seems like this is almost exactly what you're talking about. So how far out do you think this is, or is this what you're working on right now?
Wow, that's good. I don't know. Like we're making good. We've had a lot of success. So I'm encouraged. I feel like we can do well. I will say that I'm also like not talking about AI so much. And so obviously we have to have smart robots, not just physical robots. So that's one part that we have to solve a lot of the issues that represent the gap. But I also do feel like we can co-design. We don't have to make it hard for I would say if I want to go even further, I think we're at a place where maybe we should even come up with an entirely new language for people to speak that computers understand better. Co-design the thing, make the environments easier for perception and everything. So I think if we pull together all the people, we can make good progress. And there's a lot of people that are disturbed and working on this. So I'm encouraged. That's all I can say. Really, I can't know for sure. Any other questions?
Yeah, so when I was in graduate school, we had this project from IBM, and we were going to get rid of all the radiologists with knowledge-based systems, and that was the 90s, and that didn't work. Radiologists are still here.
Yeah.
So what's different this time?
What's different is big data and deep neural networks. I mean, we basically and Moore's law. Basically, if it took. When I was in grad school, I did neural networks. And this is it's crazy now. It really is that Hans Moravec wrote this incredible book on the enabling things, just brute force, Moore's law. I mean, we have Moore's law, and we have the internet. Those are it's the perfect storm, big data, really fast. And basically also Jeff Hinton says that neural networks scale really well. So you give them more data, you make them faster, bigger, they scale. So they've scaled to the point now they're doing as well as humans on radiology tasks. I mean, this is real. I mean, it's happening. So, I really do believe in brute force. I don't think there's anything particularly remarkable about human intelligence. It's just, it seems that way because we can't really even understand how it works. But that's no reason to believe it. It's just, I feel like brute force will do better with enough resources. So that's, any other questions?
In your discussion of economics, you said providing a basic income would cost $1 to $2 trillion. There's still a lot of very wealthy people left in that. And do those estimates take into account the possibility of a highly progressive tax system like we had back in the 50s?
Yeah, so I don't want to get into that. That's but yeah, so that is an option. But then it's a complicated dynamical system because economics are really weird. And you could, basically, if you don't have people that can afford things, then you stall the economy. And so you erode the tax base. And so, definitely we're going to have to tax more wealthier people for sure. I think that's a no-brainer, but even the wealthy people might not have money if they can't sell products. And so there was even a leaked article that was talking about how, wealthy capitalists should sell to wealthy people because they're going to be the only people with money later. But that's going to be a fewer and fewer, a smaller group. And so, I don't think it works out on its own. And in a way, I'm just kind of like doing the belt and suspenders approach here. I think it would be great to redistribute wealth with guaranteed basic income, but I don't think it's practical. Any other questions?
Yeah, maybe I'm missing something here. The robot's not going to feed me, and it needs energy that has to be bought from some corporation. It needs to be repaired, and it's going to go obsolete in 6 months anyway. So
yeah. So we have to solve a lot of problems. I'm not saying that we don't, but it's a moonshot. Like, we have to do it. We're in really bad shape. Is the way I'm saying. I'm thinking. But I do think that. A lot of those things, also I should say that a lot of those things are going to happen anyways because they're good for people starting companies. And like, you look at every startup in Silicon Valley, it's like automate this, automate that. So the cost of things is going to go down a lot. And it's going to be, and we're also going to face a growing energy crisis. So we're going to have to figure out how to be better, more energy efficient. And so, but I don't think it's beyond, it's complete science fiction to imagine robots that could be self-charging, teams of them. People have even built systems like that where you could have a roving team that could be charging and then deployed, and and then there are going to be tasks that are going to be harder, and I'm sure you can come up with things that are really hard, but I'm just trying to lower the cost overall of the things that will really give us benefit as a society. Not there's definitely going to be challenges. I'm not saying there won't be.
But and how does that benefit get distributed to the masses rather than to some lucky corporations?
That's what I'm saying. As a society, we got to kind of, do something that amounts to, a gift to society. An entitlement, an amendment, some ability. There's historical precedent for some of these things. It's not, beyond the realm of possibilities. Could start at the state level, and then be successful there and work to the federal level. But we're gonna have to try out a lot of different things. Okay.
Okay, well, thank you.
Yeah.